Hey there, so far you've learned about translations and reflections. Now we're moving on to looking at rotations. We're going to do rotations about the origin, and we're going to talk about how to do it when it's about just any point in general that's not the origin. So the definition of rotation, it's a transformation that turns every point of a preimage through a specified angle and direction about a fixed point. And so you can see this diagram here. We have our preimage ABC. We have a 90-degree counterclockwise rotation, so our fixed point is P, and we end up with an image A prime, B prime, and C prime. And so we're gonna go through and show you how we're gonna move everything around on a coordinate plane. Okay, so the center of rotation is that fixed point of rotation. So this point P is our center of rotation. We're gonna do a lot of stuff with the origin. And the angle of rotation is the angle between a preimage point and corresponding image point. And so when you're identifying this, you can do it between A or A prime. That angle that's formed to the point of rotation here would be the 90 degree. The same thing should happen if you were to connect from B to that point and B prime to that point, and same thing for C and for C prime. So for example, if I have this lovely triangle, I'm going to rotate it a certain amount, and specifically I'm going to do it a 90-degree rotation. So that's my center of rotation. In this case, I'm going clockwise. And so we'll talk about how we know counterclockwise or clockwise and what happens there, okay? So if we rotate ABC 90 degrees clockwise about point O, the following image is going to be produced. And so what we could really do is use a piece of transparency paper if we really wanted to go about any point. But what we need to identify here is we have a 90 degree, we're going clockwise. You're going to be told clockwise or counterclockwise. We have the original preimage, and then we have our image. And when we were to connect those points A to A prime, because this is A prime over here, you're going to see that we have a 90-degree rotation. Okay? Oh, sorry. And the key thing here is that that new triangle is going to be congruent, because we're not changing anything about its size or its shape or anything like that. We are just moving it around. So just like a translation or a reflection, this is also an isometry. So the center of rotation can also be inside the shape. So this is an example where it's inside the shape. It's not going to do anything different. We're still going to rotate this guy. We're going to do counterclockwise about point O. And what we see there is it's just going to rotate right on top of itself. The inverse of rotation maps the image that has been rotated back onto the original object. So for example, this shape here, if it's rotated 90 degree clockwise about point O, then the inverse rotation would be a counterclockwise 90 degrees. Okay, so these guys are going to be the opposite of each other. We're going to really stick to, hold on, all right, sorry about that. We are really going to be sticking to 90, 180, 270, and 360. Okay, those are the types of angles of rotations we're really going to be sticking to for these problems here. So let's talk about what happens on a coordinate plane. So for a rotation, we're going to need some kind of angle or degree of turn. So for example, we can do a 90 degree or quarter turn, or 180 degrees or a half turn, and a specific direction, so clockwise or counterclockwise. Those are the only options we're going to do, and what our center of rotation is. Now we're going to start at the origin, but we can also do it as a point like 2, 3, and we'll show you how that's going to happen in just a moment. So here's a rotation of a 90 degree, we're going to call it counterclockwise, not anti-clockwise, about the point 0, 0. So what I'm going to do is use a piece of transparency paper, and I'm going to draw it on there, and I'm going to rotate this 90 degrees counterclockwise, which is in this direction. And so if I put my pencil here and I move the transparency paper over 90 degrees, this is what I end up with. Okay, so what I want to do is identify these new points. So I can see that A prime is -1, 2, B prime is -2, 4, and C prime is -5, 3. This is very closely related to the original points. So let's kind of look a little bit farther. If A is 2, 1, and A prime is -1, 2, I'm seeing, okay, I see that those points, those numbers have reversed, but that 1 has changed signs. So let's see if that happened to the other one as well. So if I have 4, 2, and I switch around, it becomes 2, 4. Okay, B prime did that, and the 2 became negative. Same thing happened for C prime. So this is one of our rules for a 90 degree counterclockwise. It's always going to become -y, x. So this will apply to whether it's going to be in the second, third, fourth quadrant, and it's going 90 degrees. It's just going to change based upon that. So since it's an opposite y, that means if it starts as a negative, it's going to change to a positive. Okay? All right, so let's do this now. Same thing, but we're going to do it now with 180 degrees, about 0, 0. Now counterclockwise or clockwise is going to be the same thing. Okay, so let's go ahead and again trace it. We're going to put our pencil down to hold still, and I'm going to rotate this lovely thing 180 degrees. And let's see what happens with our new points. Okay, so that's 180 degrees, a straight line, and I have the point -2, -1, -3, -5, -4, -2. So looking at A and A prime, I see I have 2, 1, and then I have -2, -1. So this time it didn't switch around, but the signs changed. Does that happen to B and C? If I look at B, 4, 2, and -4, -2, yes, the same thing happened. So for 180 degrees right here is our rule. If we have any coordinates x, y, we're always going to change the signs to the opposite. So that means if it was originally negative, it's going to become a positive. So in general, here is our different rules that we have. So we just discussed the 90 and 180 degree rotation. We also have a 270 degree rotation. And so what happens is they both flip, but instead of the y changing, the x is going to change its sign. Now keep in mind, if I say, these are all going counterclockwise, if I say to take something and move it 90 degrees clockwise, that's the same thing as doing 270 degrees counterclockwise. So keep that in mind that those guys are inverse operations of each other. Okay, so this is the same as 270 degree clockwise, and this is the same as 90 degree clockwise. So make sure you get this lovely chart written down so you have something to reference. And you don't have to write all these words in there. You can just write this essential thing as the rule that we want to work with, okay? But make sure you're saying the 90 degree is the same thing as the 270 degree clockwise rotation, okay? So let's do an example. We're going to sketch the quadrilateral with the vertices A, B, C, and D. We're going to rotate it 90 degree counterclockwise about the origin and name the new coordinates. And so really we don't need a picture here now that we have that rule, but the rule essentially is going to be taking the x and the y coordinate and switching them around. So the coordinates of the vertices of our image are going to take the 2, -2, and we're going to flip it around and change the y value so it becomes +2, 2. The b value is going to be 4, 1. It's going to change to -1, 4. C is going to become -1, 5, and D is going to become a +1, 5. So again, you see all the y values changed in sign, and we switch spots with the x and the y. And if I wanted, I could graph this if I really wanted to. Here would be the original image here, and when I do that 90 degree rotation counterclockwise, here's my new picture. Okay, how about you give this one a try? Go ahead and hit the pause button and try this one out. We're doing 90 degree counterclockwise. All right, hopefully that was enough time for you. This is the correct answer here. So we have the points A, B, and C. When we switch 0, 0, it's still 0, 0. When we switch 0 or 3, 0, it becomes 0, 3. 0 doesn't have a sign, so we can't make it negative. And then 3, 4 becomes -4, 3. One last point, one last example here, and then we'll get on to the practice, is to say what happens when we rotate the point 2, -3 counterclockwise about a point that's not the origin. So essentially here we have the point 4, 2. So this is a little bit different. So here's the point 2, -3. The place that we're going to be doing the rotation about is here at 4, 2. So what I see is that this is a little bit far off from where our origin is. So what we're going to do is essentially move it so that it does become the origin. And so in order to do that, I'm going to go down 2 units for the y value and to the left 4 units for the x value. Well, if I do that with the point that we're rotating about, I'm going to do that with the point that we are starting with. So like I said, the x value is changing by moving to the left 3 units. So I'm going to take the y value of the point and subtract 4 from it. Same thing with the y value. To go to y value, I have to go down 2. So I'm going to take this point and move it down 2. So -3 - 2. And I get the point -2, -5. Well, I know how to work with the origin now. For a 90 degree clockwise is the same thing as the 270 degrees counterclockwise, which is switching the x and the y and changing the x1 to become positive. So I'm going to take that -2, -5, and it becomes -5, 2. However, we had subtracted 4 and subtracted 2 originally. Again, those numbers are coming from that point that we got there. And so I need to take that into consideration. I'm going to have to move everything back, and I'm going to then add that 4 back in and add that 2 back in. And so what I have now is the point -1, 4. I'd repeat that process for all the points that do exist. So once again, just to review that, I would take whatever the point is that we're rotating about, essentially move it back and count how far over and how far down I would go, and apply that logic to the point that we're rotating. Then I would do the normal rotation using the rules that we just gave you, and then I have to move it back, and that would be your new point. get started on that practice.